One of the things I love about math is that there are a bunch of rules that we can follow, and these rules are always true. There's no subjectivity, these things, it's just steps you take in solving equations. So we're going to be looking at exponents. Properties of exponents. We need to know what an exponent is. If you had x squared, the exponent of this would be the 2. 2 is the exponent. We're squaring it. Now let's think about what x squared actually means. X squared means x times x. So if we take it up a little bit and we say, well, let's say I had x squared and I wanted to multiply it by x cubed. Think about what this actually means. X squared is x times x. X cubed is x times x times x. Well, now let's see, we have 1, 2, 3, 4, 5 x's. We can rewrite this as x to the 5th. Now what I want you to do is look at the exponents that we started with, the 2 and the 3, and then look at the exponent we ended up with, 5. This leads us to our first property of exponents. One of the properties of exponents has to do with the products. So if we had a to the m times a to the n, we could simplify this by saying a to the m plus n. We just add the exponents together. We did that in that example above. So that is our first property of exponents. Another property of exponents that we want to think about is the power of a power. So let's say we had x squared, and then we raised x squared to another power. Let's say we did x squared to the 4th. Well, we can expand this a little bit based on what we did with our first property. I'm going to rewrite this by saying, well, this is x squared times x squared times x squared times x squared. Because we know that raising something to the 4th power means that you have it written 4 times. Well, remember the property that we just talked about. If we had a bunch of things multiplied together, what did we do with all of these exponents? We added them. So we could say that x squared to the 4th was the same as x to the 2 plus 2 plus 2 plus 2, which is 8. Now, I want you to look at that exponent and look at these exponents. What could we have done a little bit faster to make this power to a power rule work? 2 times 4 is 8. So this is multiplication. I'm going to write out this rule as well. Say we had a to the m, and then we took that and we raised that to the power of n. Think about what we did with our x's. We could say that this is a to the m times n. This is a power to the power property. Now we're going to look at quotients. Quotients, that has to do with fractions. So if we had x cubed over x squared. Well, I already know that x cubed is x times x times x. And I know that x squared is x times x. Well, think about what we were doing when we were solving equations and we were undoing, we were dividing by things, because x over x is 1. Haha, they cancel. And x over x again is also 1. Cancel again. So what I'm left with is 1x on the top of my fraction. So this final answer is x, or if you want to think about it with an exponent, it's x to the 1. So now let's think about the exponents we started with and the exponent we finished with. When you have a quotient, what do you need to do to the exponents? You need to subtract them. So our property, if we want to write it out all fancy like, is a to the m over a to the n equals a to the m minus n. This property can get a little bit tricky sometimes, so I'm going to do another example right away. Let's say we had x squared again on top this time over x to the 5th. If we were to expand this, we would have x times x, and then on the bottom we would have x times x times x times x times x. Well, again, x over x becomes 1, x over x becomes 1, and we're left with 3 x's on the bottom. If we would have used our property, we would have ended up with 3. We would have ended up actually with negative 3. But if we think about our exponents as sort of weights, I have x squared on top and I have x to the fifth on the bottom, which means it's weighing down on the bottom. So in our final solution, the difference of those two exponents stays on the bottom. X cubed stays on the bottom. In this case, we can't leave our fraction hanging, so it's just 1 over. So 1 over x cubed is the same as x squared over x to the fifth. So that is the quotient property. If you know those first three properties, you'll pretty much be able to do any exponent problem. It's just that it might take you a little bit more work than somebody who knows the next three properties I'm going to talk about. These are just quick, so I'm just going to write out the rules. Let's say we had AB, and we had raised that all to the power of m. If you have some things multiplied together inside the parentheses, and you raise them all to the same power, you can separate them out and say that that's a to the m times b to the m. Sometimes it's handy to have them separate so you can simplify further using one of those first three big properties. Another way you might see this is if you're looking at a quotient, a over b to the m. Just like this one, you can take that exponent and raise it to both of them separately, a to the m over b to the m. All right, the last couple that I want to talk about are sort of special cases. One of them is with negative exponents. We had an example where if we would have subtracted, you know what, I'm going to rewrite that example again. X squared over x cubed. If we were to just subtract, we would say x to the negative 1. However, that's not how we want to leave our final solution. We don't want to have any negative exponents. But if we look at our original problem, we see that it was heavy on the bottom. So we would leave this as the x on the bottom and 1 on top. So when you have a negative exponent, all it means is it just wants to move to the other side of the fraction. So in fancy math form, a to the negative m is 1 over a to the m. This is a really, really handy property because you can never leave negative exponents in your answer. The last property I want to look at is one you actually already know. 2 to the 0. If you had a calculator, you could try that. If you remember from middle school math, 2 to the 0 is 1. How about 3 to the 0? Also 1. There's a property that lets us know that any letter, I'm going to use a again, or any number raised to the power of 0 is just 1. Another handy property to know is sometimes it simplifies a lot of your problems. So these are 4 extra properties in addition to the 3 big properties that we're going to use to solve our examples. 2x squared times negative 3x to the fifth. Remember from one of the first properties we talked about what to do with x squared and x to the fifth. We can add those exponents together, and in our final answer we can say we have x to the 7th. However, we need to think about what to do with those coefficients. We have 2 and negative 3. Remember that these two things, these two monomials, are just getting multiplied together, and since those are just numbers, just coefficients, we can just multiply those. 2 times negative 3 is negative 6. So our final answer in this case is just negative 6 times x to the 7th. While we're thinking about multiplying, let's look at another example on the same slide. Let's do negative 5a squared b all squared. We learned a property that could help us solve this using that power to a power property, or we can just expand this out. Sometimes I like to expand, it helps me organize my thoughts. This is 5a squared b times negative 5a squared b. Now this problem is exactly like the one we did above. Negative 5 times negative 5 is 25. A squared times a squared, remember you add the exponents, so it's a to the 4th. And b to the 1 is b squared. So we have our final answer that way. If we didn't remember that property, we could use another one. We could just square everything inside. That's the power to a power property. We could say negative 5 squared times a squared squared times b squared. We would end up with 25 a to the 4th, remember that one, and b squared. So either way, no matter which property we used, we still arrived at the same answer. It was just some of our little in-between steps that were different. Either way though, those rules we talked about, see why I liked the rules? They worked. We ended up with the same thing. Let's move on to some fractions. Okay, we need to remember our quotient property. I have c to the 1 on top, and I have c to the 4 on the bottom. So where are there more c's? Down at the bottom. So my final answer, I know they're going to end up down there. Remember, with the quotient property, you need to subtract the exponents. 4 minus 1. That means we end up with c cubed on the bottom, or in the denominator. Now let's look at our d's. Where do we have more d's? We have more d's on top. We have d cubed, and then we have d to the 1 on the bottom. Subtract 3 minus 1, we end up with d squared in the numerator of our fraction. So our final answer is just d squared over c cubed. Our goal is always to get each variable written only one time. Since I only have one d and I only have one c, there are no negative exponents, we're good. So let's look at another one. Let's do ab over c cubed. This is one that we can do two different ways. We can remember that there's a property that says I can just make everything in here cubed, which would be a cubed, b cubed over c cubed. Before you can know that you're done, you need to first check. Do I only have each variable written once? Yes. Are any of the exponents negative? No. So we're good. If I had forgotten that property, I could do this another way too. I could expand it. AB over C times AB over C. I don't know why it's writing so big right now. Times AB over C. That's AB over C cubed. We wrote it 3 times. Well, we can say, oh, well, that's A times A times A. I know that that's A cubed. That one's b times b times b, so I know that that's b cubed. In our denominator, we have c times c times c, so that's c cubed. Either way, we ended up with the same solution. Here we have a multiplication problem, which at first looks pretty simple, but it's got negative exponents in it. So we can do this one in a couple different ways. We can do it as a straight multiplication problem, or we can get rid of those negative exponents first. I'll do it in both ways. Now, the negative 6, he's not an exponent, so he stays where he's at. It's only the negative exponents that change. So we can rewrite this first set of parentheses as negative 6m squared over n squared. Now, in the second parentheses, we can have 3n is happy, so he's going to stay where he's at, and n cubed will come to the bottom. Now this is just a regular multiplication problem. Negative 6 times 3 is negative 18, m squared, n. Then on the bottom we can multiply those and we can say m cubed, n squared, or n squared, m cubed. Now, we're not totally done because if you look at our answer, we have more than one m and we have more than one n. So we have to simplify it a little bit further. This would be negative 18. Now, where are there more m's? On the bottom. So they stay on the bottom after you subtract. 3 minus 2 is 1. We have 1 m on the bottom. Where are there more n's? There's more n's on the bottom. So 2 minus 1, and you get just mn on the bottom. So our final answer is negative 18 over mn. If you wanted to do this as a straight multiplication problem, we could just go ahead and multiply everything. So negative 6 times negative 3 is negative 18. Remember, when we're multiplying, we add the exponents. So I have m squared and I have m to the negative 3. 2 plus negative 3 is negative 1. So now I have m to the negative 1. N to the negative 2 times n to the 1. Negative 2 plus 1 is negative 1. So we have n to the negative 1. Now we can simplify this by making the exponents happy by moving them to where they will no longer be negative. And we end up with negative 18 over m to the n. So we used different properties in each case, but we still ended up with the same solution. In this example, we have fractions again, but we don't have any negative exponents. So we can go ahead and start simplifying this. Let's multiply the numerators, or the tops, and let's multiply the denominators to the bottoms. So if we multiply the numerators, we end up with 2x squared y to the 8th. We multiply the denominators, or the bottoms, we end up with negative 4x to the 4th y cubed. That's a 4, I swear. Now we're not done yet because we have more than one variable in our problem. And we also have 2 over negative 4. 2 over negative 4 can be simplified, so we need to simplify that. 2 over negative 4 is negative 1/2. So I have negative 1/2. Now let's simplify with the variables. X squared on top, x to the 4th on the bottom. Where are there more x's? On the bottom. Now you subtract 4 minus 2, and you get 2. Do the same thing with your y's. Y to the 8th on the top and y cubed on the bottom. There are more y's on top. How many more? There are 5. So our final answer is negative 1y to the 5th over 2x squared. You don't have to write that negative 1 if you don't want. You could say your final solution was negative y to the 5th over 2x squared. While I have some extra room, let's do another example on this one. Let's look at a cubed times a to the 6th times b to the 0 times b to the 9th times a squared. This is just a big multiplication problem. Now notice that we have b to the 0, and remember that anything raised to the 0 is just 1. So that term becomes 1. We no longer have a b there. So let's go ahead and look at the a's. A cubed, a to the 6th, and a squared. Since those are all multiplied together, we add the exponents. 3 plus 6 plus 2. So a to the 11th. Now, one of the b's went away, so we just have b to the 9th. There are no negative exponents. Everything's been simplified, so our final answer is a to the 11th, b to the 9th. More negative exponents. Uh-oh, that whole thing is negative. We can solve this problem in 2 different ways, depending on which properties we choose to use. If we want to start with the negative exponent bit first, we could move that whole thing to the bottom. So our problem becomes ab squared over 4a squared b to the 3. Now everything's good. You can expand both of those out, or you can remember your power to a power rule, and we can raise everything to those exponents. So we get a squared b squared on top, and we get 4 cubed. 4 times 4 times 4. 4 times 4 is 16, times 4 again, and we get 64. Remember, you multiply the exponents, so it's a to the 6th b cubed. To be really simplified, you need to have each variable written only one time, so we need to simplify this a little bit further. Where are there more a's? There are more a's on the bottom, so we're going to keep our a's on the bottom. We're also going to keep that 64 down there since there's no other numbers to simplify with them. A to the 6th, a squared, means we have a to the 4, and it stays on the bottom. We also have more b's on the bottom. We just have 1, so it's b to the 1. Since this is a fraction, you can't leave the top of the fraction hanging, so we need to write a 1. Now I said we could do this in 2 different ways, so I'm going to show you the second way as well. We could just distribute out that negative 3, so we had 4 to the negative 3, a to the negative 3 times 2, which is negative 6, and b to the negative 3, times a squared b squared. Now we can use one of our other properties, 4 to the negative 3. Well, that is going to be, I'm just going to leave it 4 to the negative 3 for right now. And then I'm going to multiply with the variables. So we get negative 6 plus 2, so we get a to the negative 4. B to the negative 3, and b squared gives us b to the negative 1. Now we can go ahead and start moving things to where they need to be. Everything needs to move to the bottom. 4 to the negative 3 moves to the bottom and becomes 64. A to the 4th, b to the 1. Just like before, we can't leave the fraction hanging, so we need to add that 1 on top. No matter which way you choose to use it, we still ended up with the exact same thing. See the power of those rules that I love so much about math? Again, we have one that can be solved lots of different ways. I'm going to choose to deal with the parentheses aspect first. I'm going to multiply. So we can say that this fraction is c to the negative 16 over c to the negative 20. I have negative exponents. I want to get rid of those, so I'm going to flip-flop in this case since everything is negative. C to the 20 now is in the numerator. C to the 16 now is in the denominator. Now we can just go ahead and simplify this. We know that c to the 20 over c to the 16, we need to subtract and there are more on top. So it's c to the 4 over 1. There's nothing left in the denominator. Since this fraction is an over 1 fraction, think about what you know about over 1 fractions. 2 over 1 is the same as saying 2. So c to the 4th over 1 is the same as just saying c to the 4th. So our final answer is c to the 4th. We talked about several properties in this video, and all of them have their uses, and you can use them in any combination and in any order you want to as well, whatever works best for you. Let's just do a recap of those properties we talked about in this video. We said that if we had a to the m, a to the n, what could we do with those exponents? We added them, so we had a to the m plus n. We also looked at a property with some fractions. We had a to the m over a to the n, and we could subtract these exponents. Another property that we looked at was the power to a power. We had a to the m to the n, we could multiply these two. So we would have a to the mn. Then we looked at those few extra properties that are handy but not necessarily needed if we knew these first three. These first three are the biggies. The other properties that we talked about were when you had a, b to the m, you could say that this was a to the m, b to the m. It was the same thing for when you had a fraction. When you had a over b to the m, you could say that this was a to the m over b to the m. The last couple of properties that we talked about were the negative exponents and the zero exponents. So if you had a to the negative m, you could rewrite that as 1 over a to the m. And then if you had a to the 0, what is anything to the 0? It's 1. This is just a recap of all of the properties of exponents that we did in this video. This would be a good place to maybe take a screenshot or save this particular screen because you might want to have it to reference when you're doing problems with lots of different exponents in them.